All right, let's pay attention to this. As we were going through this, how could anything that you are doing on that computer, Austin, have more importance than what I'm talking about? All right. We talked about some of the technologies we've already discussed. They're in use, they're functioning, they're actively working on this in this scenario. If you can't see it, please move up so that you can see it. One of the things that we already answered is one of the examples that we had in our IP configuration, which is this local area network connection doesn't have a gateway because its gateway is on the same box as it, so it doesn't need a gateway. It automatically finds the WAN. What we were just talking about a second ago was, how do I test this connection? Well, there are a couple different ways of doing it. One of these ways is running diagnostics using the same utilities that we used before, such as ping. And if I want to use ping, I'm not doing it from a command prompt, but it's the exact same command. So if I want to access to see if this wide area network connection is actually working, I'll pick an IP address, 8.8.8.8, and the interface that I want to check, in other words, the one that I want to ping from is X1, or ping 2 is X1. Let's go. And now it will either tell me if it's successful, 8.8.8.8 is alive, ping time 16 milliseconds. That millisecond, 16 milliseconds versus 300, what is that called? Yes?
That's the ping speed, ping.
The speed, there's another shortened version of that, yes. You guys use it all the time in gaming.
Lag.
Lag. Right, it's lag. Okay? All right, this is the kind of speed you should expect, 16 milliseconds down here on the bottom. Okay, so we're using ping. We can use Traceroute is another one. Again, it's not in a command prompt, but it's the same tool that we've used from the command prompt. So if I want to see Traceroute to 8.8.8.8 to see, what am I going to determine by using Traceroute? Yes? Number of hops. And what's another name for hops, Miguel? What are the hops representative of? It does. If the more hops you have, probably the longer it's going to take. But each one of those hops there's another name for those hops. What is it? It's going to give me the IP address of each of those hops. What are they? Taylor Early, what are those hops called? Every one of you should know this answer. Larry?
Routers.
Routers. Okay? So, I'm pinging 8. Allow once. It's blocking that pop-up. Come on, hurry up. Let's try it again now that pop-ups are allowed. 8. Go. Traceroute response at the top. Hey, when I logged into this server, or when I logged into this firewall, I included a username and password. What kept that username and password secure? I didn't establish a VPN yet. Jake, yes?
Talking about your extranet.
No, but kind of. Does anybody know? Yes?
Just the cache.
No, I'll tell you. It's not something we necessarily talked about. Another way of encrypting stuff, if you go to a website, is using, instead of HTTP, using HTTPS. HTTPS encrypts the data using a key algorithm, using certificates and such. Okay, so here's the results of this Traceroute. I've got all these different locations. As you can see, 50.249.212.238 is the router that's attached to this firewall. And then you start going, it doesn't give you quite as much information as the command prompt version, but each one of these, 56.120, 68.87, so on and so forth. Those are different routers along the way. Okay, what I did want to show you today, though, is part of the security that I set up for this network. And part of that security includes certain firewall rules, certain policies, so on and so forth. So, let's look at these rules. What is network address translation? Same people are answering the questions every time. What is network address translation? This is in your chapter, and we've already covered it once before. Zach? Jessica? Public IP address? No, that would be DNS resolution. Keith?
It changes the IP when it goes across the router.
Right, exactly. Every packet that goes out of this router. So I've got 50 users behind on this local area network, but and they're on the 10 series network, which is a private network. Every packet that's sent from this interface or from out on the internet goes out with the IP address of 50.249.212.232 or 237. Okay, that's network address translation. So there are certain rules that go along with that. For example, if I have a web server in behind this network on the 10 series network, or if I have an extranet where I have some resource behind the secure external interface, it has to convert the incoming packets, it has to convert them to what? It has to convert their addresses from the external interface, which are all coming in at 50.249. Whatever it is, to what? Yes. To the what? Designated host, which has what kind of an address? Quinn? Did you say private? Private address. Okay, so there are 50 different computers behind this, but they're all being represented by a single public IP address when they're packets, when they're accessing websites, when they're accessing secure websites, when they're doing all that. So I have a series of rules that this firewall keeps track of all that stuff. If Jill sends a packet, hers is 10, and the router over here is 50.249, the external port, when that packet comes back, that firewall needs to know that Jill is the one that requested the website www.securerestaurantoperations.com. Okay? So it keeps track of all of those different sessions and converts the packets back so they get to the right destination. Knowing how those rules work is what allows you to successfully or unsuccessfully set up a router. In addition to that, every one of those packets that comes back in on this particular firewall, and I just need to find out where it is. Bear with me. Network. That's not it. Here we go. Every one of those packets goes through certain rules to determine whether or not they're allowed. Okay? So we have application rules, we have access rules, we have all of those kinds of things. Now, I don't expect you guys to be able to understand how all of these individually work. However, you should be able to look at this and have a basic understanding, and I'm trying to find the one place that tells me settings, those are utilities, network. Here we go. Zones. Okay? The headings here, if you can't read them. This one here, oops. Security type, member interface, interface trust, content filtering, client antivirus, client content filtering, gateway antivirus, so on and so forth. This one right here is called IPS. What's IPS? No one knows? Yes. Negative. IPS. You're thinking, what's that?
IPsec.
You're thinking IPsec, right. IPS is Intrusion Protection System. Okay, so here's how this works. I've got a WAN interface here. I've got a LAN interface here. Every packet that comes back in goes through whatever rules I set up here, and these rules determine whether or not they get inspected. They use certain rules, and they check those packets. What do they check those packets for, Frank?
Make sure they should secure.
Make sure, if it's a secure network, make sure it's secure. What other kinds of things? What else is this firewall going to do? Which is, by the way, a $3,000 firewall. Jason?
Make sure it is what it says it is.
Make sure it's coming from where it says it's coming from, making sure that the data on it is what it says it is. Inspecting the gateway AV. This is the gateway. Gateway AV. What's that, Larry? AV. Anybody know, how many know what AV is? Zach, what's AV?
Antivirus.
Antivirus. So it inspects every one of those packets to determine if there is a virus or malware embedded into those packets. It looks at them to see if any of them are malformed. What do I mean by that, Austin? Huh? What would a malformed packet be an indication of, Quinn? Christopher? What would a malformed packet be an indication of? Jessica? Huh? Could be packet loss. It also could be something else. Taylor? No, not necessarily encrypted. Yes?
A packet that may have a virus.
A packet that may have a virus inside of it. And that's a packet that gets intercepted, right? Changed and sent back. Or forwarded on. Okay? So this firewall does all of the things that we're talking about in the latter part of that chapter. Content filtering, intrusion protection, network address translation, stateful packet inspection, stateless packet inspection. Stateless packet inspection is being done on the LAN interface between packets that are traveling within the LAN because we don't really care to intercept those packets, interrogate them, take a look, inspect them, and see whether they're good or not. Stateful packet inspection is taking place. What's the downside of stateful packet inspection? Two things that could be a downside. Just hold your hand down. We've got one user. Come on. What's the downside of stateful packet inspection? No one? Yes, keep. Now, you would think that you want every single packet that's possibly being brought into your network inspected rigorously. Okay? What would be the downside of that?
Might send back packets that aren't necessarily threatening.
So, false positives, we call it. Send packets back that are, yes?
When it takes long to.
It takes time, okay? It degrades performance. Otherwise, you'd inspect every packet that goes everywhere. But it slows things down. It's an acceptable risk. There's actually another cost to that. There's another problem with that, and that's cost. Okay? As I said, this is a $3,000 router or a firewall. In order to be able to do it and do it fast, you've got to pay some money. Yes?
Is this the router itself, or is this like on the ISP?
No, this is the firewall / router that's on their network. This packet, this routes every network from the internet to the network and vice versa. Okay? All right, I could not get to your other question because we're out of time. Guys, we're having a test on this in 2 days. You need to read through the material and learn this and get your notes up to date. I'll have an assessment out there tonight, late. Turn that off, please. Thanks.